homework that you had from the Ed puzzles, didn't you have homework problems there? And so I want to take a look at some of those, and I'm going to talk you through the process there because I gave you a little more advanced than Algebra 2, but not quite up to pre-cal level on the Ed puzzles, because we did learn those things in Algebra 2, and then I gave you homework from pre-cal. So there should have been a little bit of a hopefully productive struggle on some of those problems. Hopefully you figured them out. But give me questions about what you had on your homework. 21? Did you say 21? All right, 21. 21 was f of x equals 1 over 2x and g of x equals 1 over 3x. And this said to find f of g of x and g of f of x. So typical composition problems, and then it asked you to state the domain. The most important thing to get from the domain is to remember, as you look, if there are things left out of the domain of the individual functions, you also have to leave that out of the composed functions. So in other words, here, what am I leaving out of the domain? What can x not be? 0. Why? That would make the denominator 0. So x can't be 0 here or here. That domain restriction is going to carry through to my composition. Even if the composition doesn't show that, it's still going to be left out of my domain in the composition. Okay, so let's compose f of g of x. So g of x is going to be 1 over 3x, right? So I'm plugging 1 over 3x into the x in f. So 1 over 2, but it's not x anymore, it's 1 over 3x. Yes? Does everybody remember function composition? And so I have, and I'm going to just simplify this and clean it up a little bit, 1 over top times top, bottom times bottom. Now because I have a fraction in a fraction, what I'm going to do is multiply by the reciprocal of the bottom. So the top times, it's not going to be 2 over 3x, I'm going to make it 3x over 2. So f of g of x is 3x over 2. Now remember, I told you about that domain restriction. Even though here, if I were just to graph 3 over 2x or 3x over 2, that would just be a line, right? And there are no domain restrictions. But because of that domain restriction in the very beginning, I need to restrict it here and say that my domain is going to be anything except 0. Does that make sense? Because it was initially restricted, I have to keep that restriction in here as after I compose it. You don't want to leave a fraction in a fraction. I did. It should be on there. Yes, it's recorded. Yeah, I got to do the other way. That's only half of it. The domain is coming from the domain of f of x and g. They both already had that domain restriction. Yep. All right, so now let me come and go the other way with it because it asked me to do g of f of x. So g of f of x. So this time I'm taking g and I'm replacing this x with 1 over 2x. So I get 1 over 3 times 1 over 2x. Same exact process here. 1 over and now multiply by the reciprocal. So top times flip the bottom, and I get 2x over 3. And what's the domain there? Same thing. Same thing. Yes or no? Yes. Yes. And the answer. And that's important because if the answer had something in the bottom, I would also need to leave that out. You see what I'm saying? Like if it was x plus 2 in the bottom, I'd also need to leave out negative 2. Does that make sense? Almost. When I got sick Wednesday and left, I left him in my car. I forgot. The other half of the test. That was my fault, really. Yeah, the graphing one. Nobody says been terrible so far.
I feel like there's a lot of points.
Huh?
There are a lot of different points.
Yeah, and you could miss an entire question and still make like an A.
Oh.
If you let Davis fix it, he doesn't deserve it.
All right, what else from your homework? Which other one did you say, Alex? Didn't you say another one? 23. So it says to find f of x. Oh, this is a good one. All right, so it says find f of x and g of x so that y equals f of g of x. So in other words, I want something that whenever I plug it in, I end up with this. When you plug g of x in, let me ask you this. What if I told you f of x was the square root of x? Could you then tell me what g of x is? Absolutely, it could. It's just showing, it's making sure you really understand compositions. It's saying, all right, there's two different functions here. I see a square root, and since that square root's over everything, I just let that represent that outermost function because it's being done to everything. Oh, no. And then the inside is just plugged in that operation.
Oh, I understand it that way now.
Okay, so if you plug G of X. Okay.
Okay, look at this one because you didn't have 24, but let's do 24. I want y to be f of g of x. Right. Help me explain it. Tell me how y'all are seeing it.
Because
like the square is
outer
it's like the outer
Lily is an idiot, y'all.
No, she's not.
Wait.
The one big overarching operation, the one big thing that's being done to everything is the squared. So that's where that came from.
Plug into that. See G of X? That X squared plus 1 gets plugged into that.
So all this is going to go in just for this x. So that's why. So this is g of x. And g of x is... No, you don't. No, you don't. Look at 25.
Yeah, we are behind.
This is an algebra 2 lesson. That's why I gave you a puzzle on it. This is just, we're taking it a little bit further is what we're doing. That's why I'm taking all this time to go over this homework. All right, what would f of x need to be? Remember, I want f of g of x to equal y. All right, do you see that, Lily? What's being done to, what's the operation being done? Absolute value. So that would mean, what would I need to plug in for x here in order for it to look like this?
There we go.
Wait, so the F is always on the outside?
Yes.
Okay.
Yes. Like what you had in your homework? If it's in your homework, it's fair game. Yes. Yes. Yes.
Yeah, I just kind of look at them.
Or you couldn't just add.
All right, give me other questions about your homework because this was mainly composition, which we spent a lot. Remember, we did the f of g of x and it had to equal x, and g of f of x had to equal x. We're going to hit that again some more today. So I need you to understand composition. But you did composition and you did function operations last week. So this was the composition. And then operations where if I give you f of x and g of x, what's f of x plus g of x? Or f of x times g of x? F of x divided by g of x. So other questions about your homework from that? Yes. Number 9. F of x equals x squared. And g of x equals 1 over x. And they're shown in this window. So I've got, oops. Actually, a window like this. Which one is that? X squared. 1 over x. Those are parent functions that we should know, right? And so then it says, sketch the graph of the sum of f of x, f plus g of x by adding the y coordinates directly from the graphs. Then graph the sum on your calculator to see how close you came. So what does that mean? All right, so let's think about where are these crossing, first of all. At 1, 1. Do you agree with that? This is the point 1, 1. Are y'all okay there? Where are you confused? Where does x squared equal 1 over x? Oh, okay. So it says add the y coordinates directly. Right? So at 1, f of 1 is 1. G of 1 is 1. What is f plus g of 1? 2. Right? So that point would be 1, 2. So this new added one would be 1, 2. Does that make sense? Right there. Well, that's 1 point. So it said do several points. So let's pick another x. Let's say, let's go to 2. At x equals 2. What is f of 2? 4. So this point would be like 2, 4, right? What is g of 2? 1/2. So what is f plus g of 2? Add them together, right?
It's 9. You don't 4.5 plus 4 times 2.
We're not multiplying, it's just to add. F of 2, right? So it's f plus g of 2. Or you could say f of 2 plus g of 2 is what we're doing, right? So this would be 2, and then it's going to be up to 4.5. See what we're doing? Do you see here? It's making a new function. It is. And the point as you keep doing this, if you then went into okay, let's look at it. X squared 1 over x. And I'm going to adjust this window so that it looks like the window, what is this, 0 by 5 and 0 by 5. Pretty close to what's on in the book. So now if I do another one and I say, okay, this one I want to add the two together. So this one's going to be x squared plus 1 over x. We found this point, right? 1, what? 2? There it is on the green. We said it was 2, what did we say it was? 2, 4.5?
Yeah.
So 2, look at there, 4.5. You probably just didn't graph enough points to see. There's an asymptote what? There is still going to be undefined because remember the domain restrictions that happened in each one of the individual functions are still going to apply to the combined function. So because one of them was 1 over x, there was that asymptote at 1 over x. That's still going to be there. I mean at 0. Yes or no? All I did was add them. We just did it graphically instead of just algebraically. All right, what else on that set of assignments? Okay. All right, I can't tell with y'all. I'm going to skip parametric because unless you're going to do BC, calculus BC, you really don't need it. We have calculus A, B, and BC. BC is the more advanced calculus.
Wait, they actually have that here?
No.
That one's in.
Gosh, I'm hesitant to even do because we spent a long time on all this in algebra 2.
Well, I would say let's move on.
And like not even put on a test either.
So we'll spend some time talking about the inverses, but we may go ahead and jump to some transformations today, because that is so important.
These are brand new though.
Brand new. All right, tell me this. We've talked about if something is a function. How do you tell? Well, what is an inverse, first of all? Graphically, what's an inverse?
Y to X.
It's,
That's what.
I think what y'all are trying to say, the x becomes y and the y becomes x and it swaps, or it does like a rotation, right? So if I started out graphically with this parabola, what does the inverse then look like?
No, it'd be like
Sides.
Yeah, it's turned to the side. It's a rotation. That's what it is.
Right? And that's what, those are inverses of each other. But the problem is the blue a function? Yes, why?
It passes the vertical line.
It passes the vertical line test. Is the purple a function?
No.
No, why? It doesn't pass the vertical line test. How can I look at the blue and tell whether or not its inverse is going to be a function? Horizontal line test. That's exactly right. That is the horizontal line test. So here, the horizontal line test fails. That means, we've used those 3 dots in here before, right? Start getting mixed up if I've shown it with calculus for y'all. That means therefore, okay? The horizontal line test fails, and therefore the inverse is not a function. Now, Give me the equation of the blue.
No, y equals x squared.
X squared. It's parent graph, right? What is the inverse of x squared? What's the inverse function of a quadratic? It's a square root. Does the purple look like a square root graph, thinking back to your square root function? What's wrong with it? Well, how is it different? The square root is only half of that. Why do we do that? That's exactly right. For the square root, we don't have that. It becomes square root of x looks this way. We don't take the negative of it because then it fails to be a function, so we just take that. So that's why they look, even though those are inverses of each other, meaning they cancel each other out, right? What cancels the square root out? Squared. What cancels the squared out? A square root. Even though that happens, we restrict that domain so that, or restrict the bottom of that so that, excuse me, so that it's still a function. Now, let me ask you this. There are special functions whose inverses are also functions. Can you think of one? Y equals x is one. Give me another one. You're exactly right. You're exactly right. Y equals x cubed. Think about what that looks like. So this one is a line that looks this way. This one looks something like that. Both of them, however, pass the vertical line test as well as the horizontal line test. And they're special. What do we call functions that pass both the vertical and the horizontal? Somebody said it, I think. I swear I thought I heard somebody say it.
Yeah, I did.
Oh, wait. Is it like a weird word?
I wasn't looking at you. I thought somebody was at the door. I'm sorry. 1-1. 1-1, thank you. I'm sorry, Kirsten.
Yeah, look on red.
Graphs, and you tell me some things about it. Let's say I had. What is this a graph of? Look at y'all remembering these parent functions. Clearly it's a function because I said a parent function, right? Parent function. Is its inverse a function? Yes, its inverse is a function. So it is what is it? 1-1.
That's the vertical line test. And it's inverse.
Oh, so we're just identifying whether.
Yes, yes. So because it passes the horizontal line test and the vertical line test, yes, it's 1-1. All right, let's move on to the algebraic side of it. How algebraically, I'm sorry, I feel like I know I'm going kind of fast through these, but y'all remember us doing this? No, you don't remember?
Well, I remember doing it like algebraically. I feel like we did.
Yeah. All right, algebraically, how do we find an inverse? Now, here's the difference in pre-cal inverses and algebra 2 inverses. The difficulty of the equations that we are solving increases, but we're still doing the same concept. So switch x and y and solve for y. For example. Oh, what's the notation, by the way? If y is f of x, how do I indicate?
F of
Negative
F of X or negative.
Negative.
Yeah.
Y'all knew, I could see that you knew, you just couldn't get it out. They did know that. This means the inverse of f of x. Let's do one. Yes, that's the notation. Find the inverse. Solve it. Find f of. Find that. Find the inverse of f. Ooh. So we got a problem.
Wouldn't it just be one y?
Tell me what you did first. Switch what? X and y. All right, this is the same thing as y, right? So if you didn't see a y in there. Okay, so we have x equals y over y. Can't cancel because there's a +1 in the bottom too. What are we going to do?
Multiply by reciprocal.
Okay, Kirsten says multiply by reciprocal.
Wait, you
Say it again. Well, this one is in the denominator like that.
we can multiply y plus 1 on both sides.
Okay, so you're on the right track. So, if I multiplied, why are you doing that, Kirsten?
Get rid of the denominator.
Okay, get rid of the denominator or get rid of the fractions, right? So now I have x times y plus 1 equals, what's it equal? Y. My goal is to do what?
Get rid of the x by itself.
Get y by itself, right? I have a problem because I see two y's in here. What am I going to do? Okay, subtract y. Now what can I do?
Add like term.
You're exactly right, Kirsten. Distribute the x. Somehow or another, I'm going to have to get this broken apart so that I can get the y by itself, right? So, I can't just drop it. Well, I think that you're thinking a quadratic. This is not necessarily a quadratic. It's just I'm solving for y. But y is in there twice. And I've got all these variables. Okay, what can I do now? There's one piece I don't need on that side now. Which one is it?
You can get rid of
I mean, you can add the y.
subtract the y.
No, you add the y.
Well, hold on, but I guess
Divide by y.
All right, let's think about this together. What are we solving for? All right, here's one and here's one. I don't need this. So let's move that one over here and let's get this xy minus y equals x.
Divide that x by x.
what is
Somebody in here knows how to do this. I know you do. Oh, you do? I'm sorry. Thank you, Lily. Thank you. Nobody?
You divide by
Divide by negative.
my negative?
Would you add the
find
y?
the domain.
Divide by negative.
Multiply by the reciprocal.
Oh.
You factor.
Okay, how did you get that?
Oh, because you just factor out y and then it would be x minus x.
Duh.
Oh. Can I take, okay, I need y by itself. Essentially what I did, Okay, follow me through on this for just a minute. I really just combined like terms is what I did, right? If you have 2x minus 5x, okay, then I do 2 minus 5 times x, right? I did the same thing, x minus 1 times y. I essentially just combined like terms or factored the GCF out, factored the y out. Okay, now can I get y by itself? Yes. Divide. So what is the inverse of f?
Can you make it x over x?
I'm glad we decided to take a day on this. No, you need to leave it like that.
You just change the signs. You could just change the signs.
Okay on this one, but it's not always like that, no. Let's do another one. Like a puzzle. This one's coming from your home. Well, this will come in one of the Ethan's from your homework.
Can you go back up or go back to that real quick?
Yes.
I was confused.
Like, I'm
Ready? Find the inverse. This one might end up doing the same thing. Y'all got it? As you work through this one, just a little alternate. I like to show you other ways if things don't really make sense. Yes, we can multiply by y minus 2 on both sides. It's the same thing here, but should we have a fraction equaling a fraction and that doesn't help us, you can always cross multiply. Y'all remember doing that?
Oh, wait.
You get the same thing here. You get the same thing because in this case the denominator is 1, but if the denominator were anything else, then multiplying just by that one denominator wouldn't help you as much. So, all right. What did you do now? Distribute. I would also distribute now. All right, so just like when we're solving a regular linear equation, we want the variables that we're solving for to all be together on the same side and everything else on the other side where we don't want it, right? So anything that has a y in it, I'm going to put it on one side, and anything that doesn't have a y in it, I'm going to put it on the other side. So in other words, this one I'm going to bring over here. I'm going to leave this 3, but this negative 2x I'm going to put over here on this side. So I want all the y's on one side together and everything else on the other. And I'm not saying just the x's on the other side because there could be other stuff too. I just want all the y's on one side and everything else on the other. So this becomes xy. Remember I subtracted that y, so minus y equals, there's a 3 over there, but I'm also adding this 2x. Does that make sense? All right? How might I solve that for y? Factor out a y. So I have y times minus 1. Now what? Exactly. Divide by the x minus 1. So I have y equals 3 plus 2x over x minus 1. So this is the inverse. Just taking those algebraic solving skills up another notch. Yeah. How about this one? One more, and then I want to show you one more thing. Not tonight. Alice, you're worried about those word problems, aren't you? You must have had a slack algebra 2 teacher. God, I can't believe the nerve of some teachers. They don't even take their job seriously. Find the inverse. I would complain if I were you. What'd you do now? What'd you switch x and y?
I squared x.
Okay. Okay. Cube root. The inverse here is the cube root of x squared minus 5. Everybody good? For right now, yes. Yeah. All right, let's do some confirming. But it's not yet. In Algebra 2, we confirmed and verified, that two functions were inverses of each other by doing something special. Do you remember what that was? Plugging in what? And what happened when we did that? It equals x. Good job, Adam. You remember. It equals x. So if two functions are inverses of each other, let's say I have f of x and I have g of x. If these are inverses, then that means to confirm or verify. And if you think back when you took this test, I told you this is one of those problems where I'm telling you what to do, I'm telling you the answer, your job is to show me everything in the middle, and you had to show me step by step. Remember, one thing canceled at a time, and you had to show me the order in which it canceled. So that's what we're kind of back to, and I just want to take just a minute, and I'll do the hardest one with you here to make sure you can verify. It's got to simplify down to just x. Both ways. F of g of x. You don't remember doing that?
I mean, kind of.
It simplifies down to just x. When you plug one into the other, it will equal x. Yeah. Yeah. All right, let's do it. This is number 32. I lied, Alex. You're going to have one word problem. One, but it's not a word problem like we're going to talk about it. No. I'm working out evens and I'm giving you odds. Because they look like the other problems. So if you're on 31 and you're stuck, you can look at 32 as an example of how to do 30. That makes sense. Verify that these two are inverses. Or confirm algebraically that these two are inverses. That means I'm telling you they're inverses. It says that confirm by showing that f of g of x equals x and g of f of x equals x. So let's go forwards first. Yes, you got to plug it in twice. Now look, we're going to have fractions and fractions. So remember, the difference in Algebra 2 and here is my level of difficulty with my functions that I'm working with, right? So now I've got some nasty functions that I'm trying to simplify down and work with. So I've got to use all of my algebra skills that I have acquired over the years. All right, so this is f of 2x plus 3 over x minus 1. All right, so I have, it's not x, it's 2x plus 3 over x minus 1 plus 3. Don't let this intimidate you. Don't look at this and go, nope, nope. Because it's a lot, it looks like a lot, but if you take it piece by piece, it's not that bad. Whenever I teach complex fractions, I always tell everybody they look worse than what they are because take them in pieces. Do the top part first, do the bottom part first. And essentially, that's what this is a complex fraction. So let's look at the top first and see what we can do with just the top. Just this. So if I have, and I'm just going to come out to the side and do this as a separate problem. Put this over 1. So I have 2x plus 3 over x minus 1. And my goal is to get this is to just one simplified fraction. How do I combine those? What do they need? What do you have to do? The same denominator. So the second one needs what? A whole x minus 1. Sure. As long as it's the whole piece being multiplied there. No, I'm only because what I'm doing is I'm multiplying by 1. Okay, so I'm finding, think about if you had 2/3 plus 1/5. That's a terrible example. 2/3, let's make this. If that was my situation. This one only needs a 4, but I do it to the top and the bottom. This one doesn't need anything, so I leave it alone. All right, so now my denominators are the same. Do you agree? So this is 2x plus 3 over x minus 1, and this is now 3x minus 3 over x minus 1. Are we in agreement? Okay. Because they have common denominators now, I can put them together over that common denominator. Y'all okay there? 5x over, is everybody okay there? I just wrote the top of this fraction. I simplified it down to get the top to look a little different. Y'all okay? I'm going to write top so I don't lose my place. So let's do the same on the bottom. You try the bottom. See what happens to the bottom there. Put that 2 over 1. Find a least common denominator and see what happens. Yes. And this is only one way.
Oh,
Be very, very careful about that minus sign in the middle. Just the top or just the bottom, you don't do both. And since I've got a common denominator here, I'm going to do it to the top. I can come up with a project for you today that will illustrate the real world value in this concept. Some of you won't ever use it again. Others of us will. All right. I hope you got 5 over x minus 1 for the bottom.
But like I did just change it to minus. I just
That's fine.
X's cancel out.
yeah, it'll be 3 minus x.
Wait, you will still have
Remember, essentially, I'm subtracting everything up here, so this was 2x plus 3 minus 2x minus 2. So now it's time to put them together as just one fraction. So up top and on the bottom, what do I do when I have a fraction of a fraction? Fraction and a fraction. Multiply by reciprocal. Take the top and multiply by the reciprocal of the bottom. Now I have some things that are going to happen. This is 5x times x minus 1 over 5 times x minus 1. Remember what my whole goal in the very beginning was? To show, I didn't tell you, to show that f of g of x equals x. What can I do? Tell me. What happens there? Isn't that what I wanted?
Yeah, but like you still have to solve it.
No, no equation to solve. I'm just simplifying down.
Wait, where did you quadratically stuff?
All right, so I went through and I simplified the top, and then I simplified the bottom, and then I put them together.
How did you know? Isn't there a lot?
No, remember this one was, I need to show that f of g of x equals x. This is one that says verify or confirm inverses. Yes, yes. That was half the problem, Ethan.
Wait till like. So when you had the bot, like when you separated the two fractions, how did you know that the exponent was
Yes,
and you only did that on the bottom one?
yes. It's always top times flip the bottom. Where are you confused?
Oh wait, okay, wait. I was trying to multiply the bottom by a
I'm going to leave you to finish the other half of this on your homework. So you will have 32, the other half. That's just half. Right? You don't understand?
I'm not getting that. Hang on. Can you look at that?
Oh my.
Can you look at
Mama,
that?
gee. Yo,
The
Chase, what? Do it. Hey. Oh yeah, I forgot about it.
So now you have to go backwards with it. You have to do g of x plus 3 over x minus 2. You have another one like this too. The others should go really quick. These are the only ones you'll have that are bogged down. 1.5 hard problems. That's not much. All right, let me read you the word problem quickly because I want to make sure. I say word problem, but word problems lose their words in it, but everything's spelled out for you. So this is number 34. 33 is modeled exactly like it. The formula for converting Celsius temperature to Kelvin temperature is K of x equals x plus 273.16. Did y'all know that? You should have known that. And the formula for converting Fahrenheit to Celsius is, what is it? Part A asks you to find a formula for the inverse of C. You see what I'm saying? It's a word problem, but at the same time, it's not a word problem. They give you C of x, and then they ask you to find the inverse of C of x. Yeah, and then, so switch x and y, so it's going to be x equals 5 over 9, y minus 32, and solve it for y. Part B asks you find K of C of x. What does this notation mean?
Good morning, Camden High School. Please stand and join me for the Pledge of Allegiance.